All right, so we're moving on to theorems and postulates. This is section 1.5 in your geometry textbook. So we're going to start off just by defining what is a postulate. All right, a postulate is an important statement that we are just going to accept without proof. All right, so it's some important statement in geometry, of course, not just a random one. Okay, and we're going to accept it without proof. That is accepted. And then for without, I'll do W/O, right? That means without proof. All right, so we're accepting some statement with no proof of it. So here's our first postulate. It's postulate 5. It says that a line contains at least 2 points, and then a plane contains at least 3 points that are not all in one line. And then space contains at least 4 points, not all in one plane. Well, space we're going to get into a little bit later, so don't necessarily worry about that one for now. But obviously we know that a line contains at least 2 points, and then a plane is going to contain at least 3 points, and they can't all be in one line, right? We know that 3 distinct points are going to determine one plane. All right, postulate 6, through any 2 points, there's exactly one line. There's not more than that. A line is straight. Saying straight line is actually redundant. There's no such thing as anything but a straight line. So that's the only line we can draw through those 2 points. This doesn't work. That's a curve. This doesn't work. That's a curve. It must be straight. So through any 2 points, there's exactly one line. Our next postulate says through any 3 points, there's at least one plane. And through any 3 non-collinear points, there's exactly one plane. Well, we know through any 3 non-collinear points, we can draw only one plane. And then what about this first part where it says through any 3 points, there is at least one plane? Well, that's saying, what if those 3 points are collinear? We don't know if they're collinear. If they're collinear, we can draw an infinite amount of planes through those 3 points. Okay, when they're non-collinear, there's exactly one. If they're collinear, there's an infinite amount. So if we have 3 points and we don't necessarily know if they are collinear or aren't collinear, we can say, well, there's at least one. Maybe there's one, maybe there's infinite. Postulate 8 states if 2 points are in a plane, then the line that contains the points is also in that plane. And that makes sense. Let's say we have this plane here. Here's 1 point, here's another point. If they're both in that plane and I draw a line going through those 2 points, that line can't jump up off the plane. It can't all of a sudden cut through the plane. Right? It's just going to stay right along that plane as it passes through those 2 points that also fall on the plane. Postulate number 9 says if 2 planes intersect, then their intersection is a line. We've discussed this. We've taken a look at this. I'm going to do a really quick drawing for that. And maybe it looks something like this. And we say, oh, they're intersecting right along this line right here. I know that's a pretty bad drawing, but we've talked about this, how 2 planes intersect along a line. So next we're going to talk about what is a theorem. Okay, a theorem, again, is an important statement, but this time we do have to prove it. All right, so this is some important statement, an important statement that we must prove, or that must be proved. Important statement that must be proved. Okay, we can't just accept this, it must be proved. We will not prove all of the theorems that we see this year, but we do need to understand we're not just allowed to say, oh yeah, it works. Okay, it's proved that it does work. Whereas postulates, we can just accept, yep, that works. I repasted postulate 9. Okay, this should have been our theorem 1.1, which says that 2 lines intersect at a point. And this is something that we've looked at before. So 2 lines intersecting at a point. Well, we know that has to be true. It can't intersect at 2 points because then that would make a line and they would have to be on the same line. That doesn't make sense. If 2 lines intersect, they must intersect at exactly 1 point, no more than that. Theorem 1-2 states that through a line and a point not in the line, there's exactly one plane. So here's a line, here's some other point not in that line, and we're saying it's containing exactly one plane. There's one plane that contains them. Well, that makes sense because we know there's 2 points, at least 2 points that fall on that line, and this third point falls off the line. So now I have 3 non-collinear points. Well, through 3 non-collinear points, there's exactly one plane. And finally, Theorem 1-3 says if 2 lines intersect, then exactly one plane contains the lines. So let's draw 2 intersecting lines, and this is saying, all right, these must be contained on exactly one plane. Well, let's see why. So let's label 1 point of their intersection, and then I'll label 1 more point that falls on each of the lines. Okay, now I can clearly see I have 3 non-collinear points, so they must be contained by exactly one plane. All right, and then if these 2 points, these 2 blue points right here, are on this plane, then that means the line that contains them, which I'll just call line L, also has to be on the plane. And same thing, if these 2 green points are on the plane, then this line, which I'll call line M, must also fall on the plane. Hope that this helped you guys out, and best of luck on the homework.